rational expressions. This is a unit that is very algebra based, and if you do not pay attention and do not keep up and do not do the homework and do not practice the questions that I give you in class, you'll be lost. People either do really well in this unit or very terrible. There's no in between, because they'll just be stuck and not know how to do the different questions. So there's no time to be on your phones or not pay attention. All right. If we can't do today's lesson, multiplying and dividing is impossible, because you're literally just taking this and extending it. So we're just looking at today's lesson. So we'll be very, very, very closely following along. So here it says, express the rational expressions in simplified form, stating the non-permissible values as restrictions. So we will always state non-permissible values first, okay? And non-permissible values only come from where? The denominator, because the denominator can't equal 0. So you only end up with non-permissible values if your denominator has a variable in it, okay? Does this denominator have a variable in it? Yeah. So what we're going to do is we're going to put brackets around monomials. So if you look at this one, both of these are monomials. The numerator is a monomial and the bottom is a monomial, which we discussed in grade 10. Monomials is one term. Terms are connected by plus or minus signs, correct? So do either of these have plus or minus signs in them? No. Monomials are the easiest to do, but are done the worst. It's kind of crazy how that works for you guys. I can give you the most like crazy rational. You guys can do it. I give you a monomial and you're like, I don't know what to do. Okay? So if it's a monomial, if the numerator has no plus or minus signs and the denominator has no plus or minus signs, what we do is we just put brackets around all of the separate things. So I'm going to put a bracket around the 12 and a bracket around the x squared, because I can put brackets around things that are multiplied, right? Like if I said 2 times 3, I could write it like this, could I not? Isn't that 2 times 3? Yeah, same thing. 12 times x squared. I can put in brackets because they're just multiplied. Okay, and then the 2 and the x go in brackets. Now before I go on, before I try and simplify anything, I always have to state my NPVs. So before you, like, if you the moment you go to cross something off, you're like, nope, stop. Have I stated my NPVs? Because my non-permissible values or my restrictions have to be stated before I cancel anything off. Okay? So my one thing is a 2. Okay, so I say non-permissible values. So I say 2 can't equal 0. Is that a non-permissible value or just a true statement? Just a true statement. So we can cross that one off because it doesn't actually give me a non-permissible value. And then my other one is x can't equal 0. Done. So my only non-permissible value is x can't equal 0. And if I check it out, it will make my denominator 0, right? So if I fill a 0 in here, I go 2 times 0 and I get 0. So I know I'm right. Correct? Okay. So then we have 12 and 2. What can I take out of 12 and 2? I can take a 2 out of each. And when I take them out, it's division. Okay? So 12 divided by 2 is, how is this red and then this is red? Bless you. 12 divided by 2 is 6. 2 divided by 2 is 1. And then I can take an x out of each, correct? So when I take x squared and I divide an x out, what am I left with? X. And then I divide an x out of x and I'm left with nothing, right? A 1. So if I go 1 times 1 times 1, what am I left with in the denominator? 1. Because these crossed off lines, those slanted lines are just 1s. So in the top, I'm left with 6x. The denominator, I'm left with a 1. Do I need to write that denominator?
No.
That is a woodpecker, just so you know. Not even joking. 6x is the answer. So if your denominator is a 1, you don't have to write it. If your numerator is a 1, you do have to write it. Because let's look at this. If I give you a quarter, is that the same as 4? Can I drop the 1 off? No. But if I give you 4 over 1, is that the same as 4? Yes. So if your denominator has a 1, you can cancel it. So it's going to be 6x. X can't equal 0. You always follow behind with your non-permissible value. Okay, we're going to look at B. B has a plus 1 a minus 6, a plus minus 7, a plus 1. So they're already factored for you, right? Yeah.
So just saying, would the 1 be non-permissible value, or does that not count?
No, because one's a number.
Okay.
You can only get non-permissible values from variables.
Oh, okay, sorry.
Yeah. So we have a plus 1, a minus 6, a minus 7, a plus 1. They're all factors, right? So they're in factored form already. So we can go right to our non-permissible values. So we get a minus 7 can't equal 0. A plus 1 can't equal 0. Whatever's in the brackets, you set not equal to 0. What am I going to have to do to the a minus 7 one to get a by itself? What do I have to do? Yeah, add 7. So I get a can't equal 7. What do I have to do this one? Minus. What do I have to do? Get a by itself. Minus 1. So a can't equal negative 1. And then we write them together. So a can't equal 7, comma negative 1. So once I have my non-permissible values done, then and only then can I go and actually cancel off things that match. Now, if it's monomials, I can cancel off things. I can take things out of each of the monomials. If they're binomials, so binomials means two things connected by a plus or minus sign. So this is a binomial. This is a binomial, a binomial, a binomial. Do you see that? They're all binomials. In order for you to cancel binomial off, it has to be the exact same in the numerator as it is in the denominator. The exact same in every single way. Okay? So I have an a plus 1 in both the numerator and the denominator, so I can cancel those off. Now some people want to try and cancel off the a's. You can't do that. Binomials can only be canceled off if they have a twin, a replicated twin in the numerator and denominator. So, is there an a minus 7 in the numerator? Is there an a minus 6 in the denominator? No, so I can't actually go any further. That is as simplified as it gets. Your guys' problem is oversimplifying. So we get a minus 6 over a minus 7, and then we can follow behind with a can't equal 7 comma negative 1. So those are, one's a monomial, one is already a GCF, or sorry, factored form. Now these ones, I get people doing this. It's completely incorrect. First off, you didn't say non-permissible values. Second off, this 8y plus 2 is attached, is it not? So, this 8y plus 2 is actually a binomial, is it not? So when I see binomials, I immediately put brackets around them so that I can't try and cross off that 8y with the 8. Do you see this? This 8y plus 2, that's a binomial. This is 8y is a monomial. You cannot cross a binomial off with a monomial. It's binomial with binomial. So this 8y is a monomial because there's no plus or minus signs. So I can put the 8 in its own brackets and the y in its own brackets. Now, I have to state my non-permissible values first. So I have 8 can't equal 0. Is that a non-permissible value or a true statement? True statement, so I can cross it off. Then I have y can't equal 0. So that's my only NPV. Now, I have an 8 in its own bracket, a y in its own bracket, and an 8 plus y, or 8y plus 2 in a bracket. So the 8y plus 2 can only cancel off if there's an 8y plus 2 in the bottom. Is there? No. But what we can do is we can see, is there maybe a GCF I can take out of that numerator? Is there anything I can take out of 8y plus 2? Yeah. I can take out a 2. So we always run equal signs down our simplification. So this equals the next one. So in the top, in the numerator of this one, I can take out a 2. This is true. When I take out a 2, 8y divided by 2 is 4y. And then people say, oh, 2 divided by 2, gone. Remember when you take a GCF out of 2 things, you still have to be left with 2 things, correct? What is 2 divided by 2? It's actually plus 1. And whenever you take out a GCF, you should always try and put it back in and see if you get what you have. Remember, that's how you double check. So now I get 8y plus 2. If I didn't have that 1, I would just get 8y, and would it match the top? No, so I would have messed up. Okay? Now the denominator has that, so this 2 can go in its own bracket. And then we have an 8 and a y in their own brackets. Now in the top, I have a 4y plus 1. The only way that's going anywhere, because it's a binomial, is if I have a 4y plus 1 in the denominator. Do I? No, so my answer is going to contain the 4y plus 1. It's absolutely going to have that. Is there a single y or a y squared or a y cubed in the top to cancel off this y with? No, so the y is staying. Now I have a 2 and an 8 in its own brackets. Is there anything I can do with those? Yeah, what can I do? Yeah, so take out a what out of each? Yeah. So 2 divided by 2 is 1. 8 divided by 2 is 4. So I end up with 1 and a 4. Do I have to show the 1?
Not really.
No. So I technically have 4y plus 1 over 4y. Y can't equal 0. Now people will still want to cross off those 4 y's. Can I cancel them off? No, because this isn't 4y at the top. This is actually 4y plus 1. And the only way it's going away is if there's a 4y plus 1 in the denominator. Is there? No. So can I cancel these 4 y's off? No. Okay, D. I have negative x plus 7. That's a binomial, right? So I'm going to put it in brackets because it's connected. And then I have over 49 minus x squared. Does anyone spot what this is? The difference of squares. 49 is a perfect square. X squared is a perfect square. And there's a minus sign between them. So it's a difference of perfect squares, right? Difference of squares. So the top I'm going to rewrite as negative x plus 7, not doing anything to that. The bottom comes out as brackets. And I get two factors. Square root of 49 is what?
7.
7. So that's going to go at the front of each bracket because 49 is at the front. And the square root of x squared is x, and that's going to go at the back. And then what do I put in between them? Positive and a negative. Now before I go to cancel anything off, I have to state an optimistic values. So I have to deal with those two factors first. So I'm going to take my two brackets. I'm going to go 7 plus x can't equal 0. And I'm going to go 7 minus x can't equal 0. Because if either of those brackets equals 0, the denominator becomes 0. Yeah?
Like on the test, would I have to show that, or can I just?
Show it. Because they want algebra and you just give answers. You're not really showing anything. And if you make it easy, which some people do, and something simple,
Yeah.
then there's no work to do. You have marks. So here, we're going to subtract our 7 over. So we're going to get x can't equal negative 7. This one we're going to, I'm just going to add the x over. So I get 7 equals x. 7 can't equal x. So my two MPDs are x can't equal plus or minus 7. Now remember, we have to have binomials that match in every single way. So some people will look here, and they'll say, cool, negative x plus 7 is the same as 7 minus x. Is that true? Well, let's look at it. We have to look at the signs in front of the numbers and the variables. Okay? So this is negative x. This is negative x. This is positive 7. This is positive 7. So are they actually the same? They are. This is negative x. This is negative x. This is positive 7. This is positive 7. They're just out of order. But they're the exact same. So what could I do to make that look more like they're the same? Can I just rearrange this one? So I can put the 7 first. It's a positive 7, so I'm going to put a positive 7 first. Minus x over 7 plus x, 7 minus x. Do you see how you have to take the sign with the number in the variable? So it's positive 7, I write positive 7 first, minus x, minus x. Now do they match?
Yeah.
Are they the same? So can we cancel them off? Because they're exact twins. So this one cancels off, this one cancels off, and people will tell me their answer is 7 plus x. It's 1 over 7 plus x, because these slanted lines are 1s, right? So if I have only 1 left in my numerator, I need to show it. And the common error is to write 7 plus x, and it will be there. So if you forget to put that 1 up there, if the whole numerator cancels off, you will get it wrong, because you'll pick 7 plus x, and it will be there. And we follow behind with x can't equal plus or minus 7. E. I have a binomial and a binomial. Do they match in any way? What's the first thing I should see if I can do? Yeah, what should I see if I can do? What could I do to the numerator? Take out a 4 and a p, yeah. So we always check if in our numerators and our denominators we can take out GCFs. It's the very first step always. So in this numerator I can take out a 4 and a p. 12p squared, take out a 4p, is 3p. And then negative 8p, take out a 4p is negative what? 2. Now this 4 and p are being multiplied, are they not? You see that? There's no plus or minus signs there. So I can put them in their own brackets when they're just being multiplied. Because when you have two brackets touching side by side, that means multiplication. Now the denominator, what can I take out? And a 2 and a p squared. Six p cubed divided by 2p squared. 6 divided by 2 is 3. P cubed, take out a p squared is p. And then negative 4p squared, take out 2p squared. Negative 4 divided by 2 is negative 2. P squared, take out p squared. No p's left. So now you see things matching and it makes you a little bit excited, like you're not completely lost, like you actually kind of have a clue what you're doing, and you want to cancel them. But you always slap your hand first and say, no, I can't cancel off anything until I state NPVs. And these can go in their own brackets as well, because they're being multiplied. So, I write non-permissible values because NPVs isn't like a set. This is what that curriculum states is non-permissible values. So I have 2 can't equal 0. I have p squared can't equal 0. And I have 3p minus 2 can't equal 0. Whatever's in brackets gets set not equal to 0 in your denominator. Okay? Now, 2 can't equal 0. Is that an NPV or a true statement? True statement. 2 can't equal 0. P squared. How do I get rid of a squared? Square root. And whenever I take the square root, I need to put a plus or minus sign in front of it. So I get P can't equal plus or minus 0. Is there such a thing? No. So we just say P can't equal 0. But if it was any other number, you need the plus or minus sign. Now 3p minus 2 can't equal 0. What are we going to have to do? Get p by itself. So we're going to move the 2 first by adding it. So I get 3p can't equal 2. And then what do I do? Divide by 3. Okay, so p can't equal 2/3. And then we can put our NPVs together. P can't equal 0 and 2/3. Now, is there stuff I can cancel off after I state my NPVs? Are there any twins? Any binomials that are the same? Yeah? 3p minus 2 and 3p minus 2 cancel off. What else can I cancel? Bless you. Yeah, so I can take it 2 out of 4, I'm going to be left with a 2. 2 out of 2, and I'm left with a 1. Anything else? A p. This p cancels completely off. This one I'm left with 1. Yeah, just the p. So on the top I'm left with 2, because 2 times 1 times 1 times 1, because the slanted lines are just 1s. 2 over 1 times p times 1. So just p. And then I have to do my MPVs behind it. P can't equal 0, or 2/3. If I look at F, F has a binomial on the top. Do you see that? F has that 3t squared minus 75 as a binomial. So technically, can I do anything to that top?
Yes.
What can you take out?
3.
A 3.
And then difference is squared.
3 and then difference is squared. So we're going to get 3. 3t squared divided by 3 is t squared. Minus 75 divided by 3 is negative 25. And then on the bottom, we have t plus 3, t minus 5. And then we were told t squared minus 25 is a difference of squares. So often, if you're sitting there and you can't get anything to cancel off, most often people are missing the difference of squares. So this is the difference of squares. T squared, the square root of that is t. Square root of 25 is 5. So on the top, we're going to actually be left with 3, and then 2 brackets. A t at the front of each bracket, because t squared is at the front. A 5 at the back of each bracket, and then a plus or minus sign. And then I get t plus 3, t minus 5. Now I see the t minus 5's cancel, and I'm excited. But before I cancel them off, I always have to make sure I, state the non-permissible values. So I take my 2 brackets and say they can't equal 0. T plus 3 can't equal 0. T minus 5 can't equal 0. Do I care about the numerators? We talked about this 2 days ago. Can our numerators equal 0?
Yep.
Yeah, because 0 divided by anything is 0. That's fine. You just can't divide by 0. So I'm going to subtract 3. And I get t can't equal negative 3. And for this, I'm going to add 5. And then I'm going to get t can't equal 5. So my 2 non-permissible values are t can't equal negative 3 and 5. Once I state my non-permissible values, I go back and I say, is there anything I can cancel off? Is there any twins, replicas, anything on here? What is there?
T minus 5.
T minus 5. So then I'm left with 3 t plus 5 over t plus 3. And then t can't equal negative 3 and 5. So when you go to simplify, you always have to check if there's a binomial, put it in brackets. Then can I GCF the binomial, or can I take out a difference of squares in the binomial? If it's a monomial, I go right to brackets. So this one here is a monomial. Do you see it? So what can I do immediately? Go right to. Do I have to take out GCFs or anything? Or can I go right to brackets because it's a monomial? Right to brackets. When you have two things multiplied together, you can always show it by brackets. This one, however, is a binomial, so I'm going to have to put in brackets and then take out a 3y, right? These are both binomials. I put them in brackets. This one I can take out a 3a squared. This one I can take out a negative 12. Okay, you're trying these out. So this one is a monomial. But before we go and cancel stuff off, we have to state non-permissible values. Our first one is 36 can't equal 0, and then x to the 7 can't equal 0. Now, 36 can't equal 0 is a statement. This is true. X to the 7, when you take the 7th root of x, or the 7th root, any root of 0, it's just 0. Now, you can look at monomials in this way. Instead of saying, oh, I can take 4 out, you could look at it like this. 18, x, 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 x. And then 36. 1, 2, 3, 4, 5, 6, 7. You could look at it that way. I can take an 18 out of both of these. So this is 18 divided by 18 is 1. 36 divided by 18 is 2. And then you could literally cancel them off like that and see you have x cubed left. Or we could do what we did before and we could say, okay, I can take off 4 of these and I'm left with x cubed on the bottom, right? You don't have to write them all out. But you do have to have equal signs. So go check if you have equal signs, because you should have equal signs running down the left-hand side the whole time because it's an expression. On the top, you just have a 1. And on the bottom, you have a 2, x cubed. And then make sure you're always sharing your MPVs behind it. X can't equal 0. B, what can I do to the numerator? Take out a 3y. I have an equal sign. Take out a 3 and a y. And then I'm left with 3y divided by 3y is 1. Minus 9 divided by 3 is 3. And then y squared divided by y is y. The bottom is a monomial, so I can go 6 and y cubed in its own brackets. Now before I cancel anything off, I have to do my non-permissible values. And they're just based off my denominator. So I have 6 can't equal 0, which is true. And then y cubed can't equal 0. When I take the cube root of 0, it's 0. So my only NPV is y can't equal 0. That's just a true statement. Now, is there anything I can cancel? On the top, I have a binomial. It's 1 minus 3y. Is there a binomial 1 minus 3y in the denominator? Is there a 1 minus 3y in the denominator? No. So I'll just rewrite that one in the numerator because it can't go anywhere because it needs a twin. Binomials need twins in order to cancel them off. And there isn't one. Okay, what about the y and the y cubed? Can something cancel out of there? Yes? What? Okay, take out a y and a y cubed.
No, just a y.
Just a y. So I'm left with y squared in the bottom, in the denominator. What about the 3 and the 6? What can I take out? 3. 3 divided by 3 is? 1. 6 divided by 3 is? 2. And then y can't equal 0. C, the numerator and the denominator are binomials. So I have to see if I can take out GCFs or difference of squares when it's a binomial. What can I take out of the top? The numerator.
3a squared.
3 and an a squared. 3a cubed, take out a 3a squared. Just a. Negative 3a squared, take out a 3a squared. Minus 1. And then the 3 and the a squared go in their own brackets. The denominator, I can take out a negative 12. Negative 12a divided by negative 12 is a. Negative 12 divided by, or 12 divided by negative 12 is minus 1. And I see some things I can cancel, but I can't cancel them off until I state your MPVs. So, does the 12 get me an MPV? Does a number in a bracket get me an MPV? Do I have to keep writing negative 12 can't equal 0 and that's a statement? Do I have to keep doing that? No. We've proven that every single time there's not a variable in that bracket, it doesn't get an MPV. So it's just the a minus 1 can't equal 0 that has to be done. Add 1. A can't equal 1. Then these cancel because they're exact twins and they're binomials. What about the 3 and the 12? Can I take something out of that? What can I take out? A 3. 3 divided by 3 is 1. Negative 12 divided by 3 is negative 4. And it equals a squared over negative 4. A can't equal 1. For Monday, I want you to do these and these. We're going to go over them right away at the beginning of Monday.
On this list, I asked them to put like 1 before an A, to dot that.
Sorry, how are you asking? Like if you put a 1 here?
Like if I wasn't taking just.
No, totally right.
Yeah.